Let's talk about conditions on the early Earth and the conditions in which life emerged. But before we do that, we first of all need to understand how the Earth formed in the early solar system. The solar system formed, like all star systems in the universe, in a molecular cloud. A molecular cloud is a region of the universe where hydrogen, helium and some other elements reach densities that are high enough for structure to begin to form and for the clouds to begin to collapse under their own weight. This is an example of one, NGC 281. It's a bustling region of star formation about 10,000 light years away. As the clouds begin to collapse under their own gravitational influence, some of this material forms a protostar, which is a region of much higher density at the centre of a nebula swirling around this star. Structures begin to form in these nebulae. For example, this is a bipolar outflow, and what's happening here is the material is collapsing into the protostar, and the new solar wind that's being generated by this early star is pushing the material out and forming these outflows around the nebula. So structure begins to form in the molecular cloud as well as the star at the centre. The most crucial event in the formation of a star system is the ignition of the nuclear furnace inside the centre of that protostar in the middle of the nebula. And this occurs by a process called nuclear fusion. This is an example of a reaction of nuclear fusion where deuterium is fusing with tritium and forming helium and also a neutron. And in that process, much energy is released. The nuclear furnace is ignited and the star produces light and energy. And it's this light and energy that will be responsible for driving the rest of the processes that are occurring in this nebula as planets begin to form. Beyond the star, in the nebula, material begins to coalesce and form planets. Beyond a line called the ice line, volatiles like water, hydrogen, helium begin to coalesce and form giant gas planets, such as Jupiter and Saturn in our own solar system. In the inner regions of that nebula, small pieces of rock begin to coalesce. These planetesimals come together and eventually form small rocky planets like Venus, Earth and Mars. So there's a very distinctive separation in the types of planets that can be formed in nebulae. Now, of course, it's worth saying that things are not quite this simple. Planets can also migrate. It's thought, for instance, that Uranus and Neptune have migrated in their past, and the solar system will also pick up rocky debris in the outer regions of the nebula. But in the inside of the solar system, in the inner regions of that solar system, the terrestrial rocky type planets will form like the Earth. And once Earth had formed, the stage was then set for conditions to become better and more appropriate for life. So what have we learned in this very brief summary? We've learned that clouds of gas form that are relatively dense compared to interstellar space. In these molecular clouds, these star-forming regions, the gas collapses and leads to the formation of a protostar. This is called the nebular hypothesis. Eventually, fusion is initiated in the star and it starts to give off heat and energy. During this process, material in the nebula also begins to collect and form planets. Giant gas planets far away from the star and rocky planets further in as material coalesces and gathers to form planets.